Good afternoon, ladies and gentlemen. You are now witnessing Unit 3, Note 6, multiplying monomials by polynomials. What that means is you are going to be multiplying powers into quotations and things like that. You'll see what I mean. It's not working. Remember your rules of exponents. There's a link there. Multiplying like bases adds exponents power of a power. Things like that. Always is 1. So I'm going to write some examples quick. This smart board is being crazy. Look at this. Nothing's going away. Here we go. Add exponents. Here's my examples. x3 times x to the 5th. That is going to equal x to the 8th. For multiplying exponents, you have x to the 3rd to the 5th power. Okay, that's when you have x to the 15th. So we're kind of showing you the difference of them, and then x to the cubed, even if it's to the power, it's still just 1. Okay, so I just wanted to run through that quick. Those are the differences. Make sure you know the differences. So here's some simplifying expressions things. You have the distributive property. It lets you multiply some by multiplying each other term separately. You have 1, distribute the monomial. So we got to work on distributing, multiply each pair, combine like terms, put your answer in standard form. That's what you got to do all of these things correctly. Pause it, write all those down in your simplifying expressions. Then we just have problems. We got a couple examples to do. So we need to do negative 2x squared to all of these. So, to practice, negative 2 times 3 is negative 6. X squared times an x squared would be 2 plus 2 is 4. Alright, negative 2 times a negative 7. You know what? I'm going to do it this way. Negative 2x squared times 3x squared minus 7x times negative 2x squared plus 10 times negative 2x squared. That's what you're doing. You're multiplying all three of them by negative 2x squared. So let's redo this. Negative 6x to the 4th. Alright, a negative and a negative. One of them has to become a positive. 14, and then we have an x to the 1. That's going to be cubed minus 20 x squared. Okay, that's your answer for 1. Let's move 2 down here. I'm going to write it out again. I like to see that. So I have negative 4a squared times 5a squared plus 2a times 5a squared minus 7 times 5a squared. So I'm writing it out. For some of you, this is a lot, really tedious. But negative 4 times 5 is negative 20, a to the 4th, plus 10a cubed, and then minus 35a squared. Alright, so that's the answer for 2 is in blue. The answer for 1 is in black. Alright, so I'm not going to write those out every time, but that's what you're doing. And you have to understand that you're multiplying and distributing each time. Now make sure some things to look at is this 4, this 3, this 2. That's standard form because it's reducing each time. And we got a 4, a 3, and a 2 here too. So the highest degree is first, which was 4. And then the leading coefficient is negative in both of them. So here, I have 6y times 4y squared is 24y cubed minus 6 times 9 is 54. Y times y is y squared minus 42y. If you can't get that, that's one where you got to come and ask me how or why. I love when kids do that. Negative 3 times 4 is negative 12x cubed. Negative 3 times negative 8 is a positive 24x to the 4th. Negative 3 times 2 is negative 6x squared. Okay, here's one thing though. This is not an answer. This is going to be incorrect. 1 point off on your quiz. You have to write it in standard form, which means you have to go in this order. Alright, there's nothing we can do about it. You have to count down the degrees. So that 4 is the highest. That has to be out front. You can't have this 3 out there. They got to switch spots. Alright, make sure you don't do that mistake on a quiz. We're perfecting ourselves. Flip it over to the back. So an overload. Alright, simplifying expressions. Maybe that slide's out of order. Whatever, I don't care. Make sure you're doing all these answers. Combining like terms by adding the polynomials, multiply each pair, distribute, all those things. Alright, if you got somewhere to write it in your simplifying expressions, go back and write it on the front. Otherwise, flip it over. We got bigger. This is where we're actually doing a lot of extra work. So, we have 4 times 3d squared is 12d squared. 4 times 5 is plus 20d. Okay, now we got to do another one. So this is going to be minus d cubed plus 7d squared, and then a negative is minus 12d. So when I order this and I write it in standard form, I would see minus d3. This is the biggest. Alright, you can cross that off if you need to. Then I'm going to d squareds. There's my d squareds. Where's all my d squareds at? That's kind of funny. Okay. 20d minus 12d. I would say it's plus 8d. This is your final answer here. And that's exactly how I did it in my paper. Actually, on my paper, I crossed off the cubes when I got there, and I crossed off the squares once I added them together. So I can make sure I'm doing things correctly. Alright, so let's try this again. So I'm going to do 3 times 5 is 15x squared. 3 times 2x is plus 6x. 3 times negative 4 is minus 12. Make sure you see this is a negative 1 here. This is like a negative 1x. Okay, so that's why on the last one I switched the sign every time. Okay, so negative 1x times a positive 7x squared is going to be minus 7x cubed. A negative 1x times a 2x is going to be minus 2x squared. And a negative 1x minus a 3 is going to be plus 3x. Right? You should see this as negative 7x cubed is our largest degree of 3. So that's first. Then I would look at this 15x squared and this 12x. Is plus 13x squared. Then I have 6x and 3x is plus 9x. Then I still have minus 12. So this is a 4-term answer here. So there's not much to simplify. But we're practicing, we're getting things done. Okay, 7 and 8. Right now, number 7, if you ever come look at my paper, I screwed it up like 3 times. Okay, so make sure you're able to pause the video right now and probably do them yourself. And then just make sure you have the right answer with me. If you can do that, then you can do the practice sheet, no problem. These are going to be the hardest ones. So 3 times 2 squared is 6t squared, minus 12t, and 15 times 3 is 45. Plus, so this is easier because this is just a plus symbol, 6 times 5t is 30t squared plus 12t, 2 times 6t. Alright, so my highest degree here is t squared. So I'm going to actually have 36t squared, so that's here and here. Now, I should see minus 12t plus 12t. That actually goes to 0. So I just have 36t squared minus 45. That's a pretty ending, but you got to be able to get there. Let's try this. 3x squared. Then the other term would be plus 4x plus 2 times 7x is 14x. 2 times 3 is minus 6. Combine like terms, 3x squared plus 18x minus 6. One thing I should have probably done on those last 5 and 6 with that negative sign is rewrite them, but just don't get confused. Couple word problems here. So, Greg pays a fee. So right here, I would say for local calls. So I have local calls. Long distance rates are 6 cents per minute for in-state. So we have in-state, out-of-state. Alright. We're going to add all those together. So here's what it says. Greg pays a fee of $20 a month for local calls. Long distance rates are 6 cents per minute, so 0.06 per minute. Ooh, hold on. I'll tell you my variable in a sec. 0.06 and 5 cents a minute for out of state. Suppose Greg makes 300 minutes of long distance calls in January. So that's in a state and out of state. M of those minutes are in state. So in state are M. Out of state, we don't know what it is. Here's your process. He has 300 total minutes. Total long distance. Okay? M of them are in state. So how many are out of state? This is something that's going to be kind of new. 300 minus however many are in state mean the rest have to be out of state. So our variable here for out of state, instead of putting a Y or a N or something silly, we're actually going to just eliminate it. We know that out of the 300 minutes of long distance, if you subtract the in-state ones, you're left with how many you use out of state. So now we only have one variable. Well, that's beautiful because I can solve then. So here's what we got. We got 20 plus 0.06 M plus, I think maybe putting that in parentheses would be easy to see, 0.05 times 300. That is 15 minus 0.05 M. Well, if I combine my terms here, I have plus 15 and 20 is 35 plus 0.06 minus 0.05 is actually going to be 0.01 M. So what that tells me is my fee is going to be $35 plus 1 cent per total minutes of in-state. So you know what? That's not too bad. If you can follow along and do something like that on your own, that's great. So let's try this last word problem. A parking garage charges $30 per month. So let's stop. We got monthly, $30 plus, you can see the plus words right here, 50 cents daytime, hold on, and 25 cents per hour during nights plus nights / weekends. Suppose Juana parks in the garage for 47 hours in January. So how many hours are there total? Total hours is 47. And each of those are night and weekend hours. So total hours, 47. Our nights and weekends equals H. That means our daytime hours plus our nights and weekends equal our total. So this is what we did on the last one too. I'm just writing it a different way. Daytime plus H equals 47. Or if I subtract H from both sides, maybe this makes a little bit more sense to you. Daytime hours equals 47 minus H. That's the math or the algebra you're doing to get that. So for this problem now, 30 plus daytime hours. Well, I get 50 cents. So I'm just going to write 0.50. What did I say my daytime hours are? 47 47 minus H, plus, what are my nights and weekends? 25 cents per hour. So 0.25 times H. So this is going to be 30 plus 23.5 plus when I distribute this, this becomes a minus 0.50H. That's why I stopped myself, plus 0.25H. Good news, I can combine like terms. 30 plus 23.5 is 53.5 minus 50 cents minus a quarter, or negative 50 plus a quarter is going to be minus 0.25H. So my bill at the most is $53.50, but if I have a bunch of night and weekend hours, then it's a lot cheaper. Okay, that's your notes for today. I know that was a little long-winded compared to the last couple, but I think that stuff's pretty important. I hope you understand how I got those daytime hours, making it the total number of hours minus the nights and weekends. That's pretty important to get because that's what your word problems, which some of you struggle with, are going to be for this practice and notes and possibly one on your quiz. All right? Don't get stressed out. Do your work in class, all right? We're winding down here. You guys got to have a plan to finish up. Thanks for being attentive listeners.